Good morning, friends. In previous lecture, we have discussed about method 1, which is for exam point of view. I have taken the same problem, cantilever subjected to point load. This method is used for person who is working in industry or students are working in final year project. It will take more time than the method 1. For that reason, you can use method 1 for exam point of view, but when you are working in the project work or in any of the industry, better you should use this approach. I will tell you how to use this. As I told you, this is the same problem which I have taken. In this, two methods are there. Either you can use right portion of the section or you can use left portion of the section. In this case, I used right portion of the section is chosen. In this, I need to find out the shear force and bending moment in section CB. For that reason, I'm going to take any section between C and B at a distance X from point B. First, you need to calculate shear force. First, take down the section in between C and B at a distance X from point B. I have taken a section here. On the right hand side, only 1 point load is acting, that is 1.5 kilo Newton, and that is acting in clockwise direction. If it is acting in clockwise direction, means you have to take it as positive 1.5 kilonewton. Except this, no other load are acting. Here you can see the sign conventions. On the right side, if it is acting clockwise, take it as positive. Next, bending moment. In this bending moment, all of you know that definition is vertical load into perpendicular distance. First, I will write a bending moment equation up to this section. Vertical load into perpendicular distance. It is 1.5 into x. Now we'll see the sign. If you see on the right side, it is acting in clockwise direction. If it is acting in clockwise direction, then you have to take it as negative bending moment. This is the one method, or this is the layman method. If it is acting downward, always it will result into a negative bending moment or hogging. That's why I've taken it as minus 1.5 into x. This is the bending moment equation up to the section, but I want bending moment at point B and at point C. Now at point B, what is the value of x? X is the starting point. From here you have taken the distance. Okay, means if this is a starting point of x, means x will be 0 at this particular point. X will be 0 at this point. Therefore, x is equal to 0. Substitute x is equal to 0 in this equation. You will get bending moment at point B. Therefore, bending moment at B is equal to minus 1.5 into 0 is 0. Now I am going to find out bending moment at point C. This is the starting point of x. From here up to C, the distance x will be equal to 0.5 meter. Therefore, at C, value of x is equal to 0.5 meter. Now substitute x is equal to 0.5 meter. In this equation, you will get bending moment at point C. Therefore, bending moment is equal to minus 1.5 multiplied by distance is 0.5. It will be minus 0.75 kilonewton meter. This is how you have calculated the shear force and bending moment in section CB. Similarly, now I am going to take down for the section AC. Here I am going to take for section AC. This is for section AC. In this case, same, you have to take a section. Take any section in between A and C at a distance x from B. Once again, I will repeat. You have to find out the shear force and bending moment in section AC. For that reason, you have to take any section at any point. Take any section between A and C at a distance x from point B. Therefore, here I have taken a section. Now you have to see the right portion. You have to use the right section method. How many loads are acting on the structure? You have to use that. To the right side, 1 and 2 vertical loads are acting. Therefore, shear force F is equal to 1.5. It is clockwise in nature. It is clockwise in nature. That's why I take it as positive 1.5 kilonewton. And this 2 kilonewton is also clockwise in nature. Take it as positive 1.5 plus 2. It is 3.5 kilonewton. In between A and C, the shear force is 3.5 kilonewton. Now bending moment equation you have to write. On the right section, bending moment equation is vertical load into perpendicular distance. Vertical load into perpendicular distance. I am finding at this section 1.5 multiplied by x, and it is acting in clockwise direction. If it is acting on the right side, if it is acting in clockwise direction, means the beam will be hogging. Or if you see the vertical load, it is acting downward, means from layman method, you have to take it as negative minus 1.5 into x, minus 1.5 into x. One more load is acting, it is also acting downward, or it is acting in clockwise direction, minus sign, minus distance from C to up to section it is acting. Therefore, you know that from B to up to section the distance is x, but I want the distance from C to x. You know that BC distance is x. X minus 0.5 meter. BC distance is 0.5. X minus 0.5 will give you the distance between X and the section. Therefore, it is X minus 0.5. Vertical load is 2 multiplied by perpendicular distance. It is X minus 0.5. 2 into X minus 0.5. It is negative bending moment or hogging. That's why I take a negative. This is the bending moment equation is for the section, but I want bending moment at point C and at point A. Already you have calculated bending moment at point C. You calculated as 0.75. Here also calculate, you will get the same answer. Now bending moment at point C. The distance of X, this is a starting point from B to C. From starting point of X to up to C, the distance X is equal to 0.5. Substitute the value of X is equal to 0.5 meter in this equation. You are going to get the bending moment at point C. 1.5 multiplied by 0.5 x value, 2, 0.5 minus 0.5. This will be 0. 2 into 0 is 0. Therefore, 1.5 multiplied by 0.5 is minus 0.75 kilonewton meter. Now I want to find out bending moment at point A. The distance is, this is the starting point. From B to C it is 0.5 meter, and from C to A it is 1 meter. 0.5 plus 1 meter. 0.5 plus 1 meter, it is 1.5 meter. Substitute X is equal to 1.5 meter in this equation. You will get bending moment at point A. Minus 1.5 into 1.5 minus 1.5 minus 0.5. Substitute the value. 1.5 to 1.5, it is 2.25 minus 1.5 to minus 0.5, it is 1. 2 to 1 is 1 minus 2.25 minus 2, it is minus 4.25 kilonewton meter. This is how you are going to get the value. Now I am going to plot the Sfd and Bmd. Already I have shown how to plot them. This is the second method. This is the given problem. This is distance is 1 meter and this is 0.5 meter. Now shear force between B and C, it is 1.5 kilonewton. Between B and C it is 1.5 kilonewton. And in the previous video I have shown you how to draw the shear force and bending moment variation. In the description I will add those links. You can see how to draw the variation. In that lecture I have shown you. You need to remember a table. If point load is acting, then the variation will be constant. 1.5 kilonewton is constant. Now shear force at point C to A. Shear force from C to A, it is 3.5 kilonewton, and here also point load is acting. If point load is acting, then shear force will be constant, 3.5, and at point A also it is 3.5. Join this line and extend this up to A. And all the values are positive. That's why I have drawn above the baseline. This is the baseline. Always positive value should be drawn above the baseline. Negative value should be drawn below the baseline. This is how the SFT is drawn. Next is bending moment diagram. This is the baseline. Here the bending moment values are negative. That's why I have drawn below the baseline. Bending moment at B, it is 0, 0. Bending moment at C, it is minus 0.75 kilonewton meter. At point C, it is minus 7.5 kilonewton meter. And the load is point load. That's why the variation will be linear. For shear stress, shear force, it will be constant. For bending moment diagram, it will be linear. Now bending moment at point C, it is minus 0.75. Already I located that. Bending moment at A is minus 4.25. Locate that. Between A and C, you can see that point load is acting, means the variation will be linear. These are the negative values. All the values are negative. That's why I have drawn below the base line. This is how you need to use this method. Thank you for watching.